Alright guys, this morning we are going to do polynomial division, and instead of long division I'm just going to go ahead and skip right ahead to synthetic division. So there is another way to do this, but all the problems we're going to work on you should be able to do with synthetic division, so I'm going to focus on that. So synthetic division is just a process we're going to go through, and to the side here is just kind of a step-by-step of what I'm going to do with this problem right here, and then we'll just go through some examples together. Now this is important. This only works for what we call a linear factor, so that means the highest power you can have is just a plain x. You could have like a 2x, or you could have a 3x, but if you have an x squared or an x to the third or something like that, this process doesn't work. So it has to be what we call a linear factor. If you look down here for my little example here, this is x minus 3, so it's just a plain x. Okay, so here's what you're going to do. We're going to see how this divides into this 5x cubed minus 6x squared plus 4x minus 1. So I am dividing this polynomial by this linear factor here. Okay, I'm sorry, not necessarily linear factor. We're going to talk about that in a second. I'm dividing by this set of parentheses. Okay, whatever you have here, this is x minus 3. So if this is a minus, I'm going to change and I'm going to write plus 3. And basically you write kind of like a capital backwards L, kind of a little box to extend out here. Then you're going to write down the coefficients of each of the terms here. So I have 5x cubed, so I just write the 5, negative 6x squared, 4x, and negative 1. So just write the numbers. And then this process, the first step is the only one that's really different. Everything else just repeats. So you do what we call bring down the first coefficient. So 5 goes underneath the line. And I'm just going to grab a different color here real quick. So what you're going to do here is you're going to take the number, the 3 here, you're going to multiply that by whatever's underneath the line and put that in the next open space. So 3 times 5 is 15. And then what you do with the numbers above the line is you add them together. So negative 6 plus 15 is going to give you 9. And then that process repeats. Let me see if I can grab a different color here real quick. So then I'm going to do 3 times 9 and put that in the next available spot. So 3 times 9 is 27. Then I'm going to add the two numbers stacked on top of each other. This is 31. And then I'm going to do that, forgive, out of colors here, one more time. So I'm going to do 3 times 31. That goes in the next available spot. So 31 times 3 is going to give me 93. And then the last step is to add these. So negative 1 plus 93 is 92. Okay, this term, whatever it is, the very last thing, this is your remainder. This is your plain number, or your constant, and then we have x, and then you start adding powers of x. So my answer here would be 5x squared plus 9x plus 31 with a remainder of 92. Now, you don't have to write this down. This is what I'm looking for as my answer. What this means is if I do x minus 3 times 5x squared plus 9x plus 31, if I multiplied that out like a FOIL, this would have to be a FOIL on steroids because we'd have 3 terms. I would have to add the remainder, which is 92, and that would give me back that 5x cubed minus 6x squared plus 4x minus 1. Now, you don't need to write that down, but that's what that means. So if I divide this polynomial given here by x minus 3, the answer is what I have here with the remainder. What it means, if we were to multiply those back together, that would give us our original problem. So my answer I'm looking for is this. And so we're just going to practice this concept a couple times so you guys get used to it, and then do a couple special cases. So divide, here's my x cubed 4x squared plus x minus 6 plus 1. Let me add one note up here at the top. If you have a remainder, which I do here, that means that x minus 3 is not a factor. So anytime you have a remainder, whatever you divide it into your polynomial is not a factor. So if you want to have a factor, it has to have a remainder of 0. Alright, so let's try this again. So here's my example. I'm going to divide this polynomial by x plus 1. So if that's a plus 1, I'm going to change this to be a negative 1. And we're going to write down the coefficients. So I have 1, 4, 1, and negative 6. First thing I'm going to do, bring down whatever that first coefficient is and just copy it under the line. So this is 1. And then you are going to put a little plus sign here. We are going to multiply, and then we're going to put in the next available spot. So negative 1 times 1 is negative 1. Add these up, we're going to get 3. Repeat that process. Negative 1 times 3 is negative 3. Add the numbers that are stacked on top of each other. It's negative 2. Negative 1 times negative 2 is positive 2. And negative 4. This is your remainder, your plain number, your x, and then in this case x squared. So my answer would be just x squared or 1x squared plus 3x minus 2 with the remainder of negative 4. Completely fine to have a remainder that's a negative number. What it means here, this is not a factor since we have a remainder, but if I did x plus 1 times x squared plus 3x minus 2, if I multiplied that out, I'd have to subtract 4 to get back the original polynomial that we started out with. What I'm looking for as your answer is this. What do I get when I divide? So this one again is not a factor. And I'm just going to try one more with you real quick, and then we'll do some special cases on the other side of this paper. So I have x plus 2. We're going to change this to negative 2. Write down your coefficients. Negative 2, 5, negative 1, and 2. Bring this down. Negative 2 times negative 2 is 4. 5 plus 4 is 9. Negative 2 times 9 is negative 18. And add these together, we're going to get negative 19. Negative 2 times negative 19 is 38. 2 and 38 is 40. Remainder, plain number, x squared. So my answer here, negative 2x squared plus 9x minus 19 with a remainder of 40. This again, this is not a factor. Alright, so I have some special cases here, and we're still doing some division, and you'll notice as my example description it says up here we're going to do synthetic division, but we're going to have missing powers of x. So what do I mean by that? So I'm going to take x to the 4th minus 3x squared minus 10 and divide it by x minus 2. So if you guys notice, and this is really important, I don't have a term with an x cubed. Oops, sorry, this is minus. And I also don't have a term with an x. So when you're doing synthetic division, it's really important. If you're missing any powers of x, which I am here, you have to replace them with zeros when you write down the coefficients. So here I'm dividing by x minus 2. So I'm going to change that to a positive 2. Now my coefficients, I have 1x to the 4th. There's no term with an x to a 3rd, so I have to write that in as a 0. Then I have negative 3x squared, no plain x, and then negative 10 as my constant. So if I'm missing any powers of x, you have to put it in as a 0 or it won't work. Go ahead, bring down the first term. 2 times 1 is 2. That goes in the next open spot. 0 plus 2 is 2. 2 times 2 is 4. Negative 3 plus 4 is 1. 2 times 1 is 2. 0 plus 2 is 2. And then finally here, 2 times 2 is 4. And this will be negative 6. Okay, remainder is always on the far right. Then we have our plain number, and then you just start adding powers of x. So this is x squared, and this is x cubed. So my answer, x cubed plus 2x squared plus x plus 2 with a remainder of negative 6. Again, this is not a factor. Has to have a remainder of 0 if you want to have a factor. And then I've got one more example here. Now this is x cubed, but I have no x squared and I have no x. and then I have 125. So any missing powers of x, don't forget you're going to have to represent those with a 0 when you're doing the synthetic division. Okay, so here we're going to do, here's plus 5, so I'm going to write negative 5 outside, and 1 x cubed, no x squared, no x, and a 125 as my constant. Bring down the 1. Negative 5 times 1 is negative 5, and then we're just going to add the numbers stacked on top of each other, so this will be negative 5. Negative 5 times negative 5 is 25. Add these two numbers, is 25. Negative 5 times 25 is negative 125. So actually, finally here, this is our remainder is 0 for this question. This is your constant, this is your x, this is your x squared. So x squared minus 5x plus 25. No remainder here, so that means that x plus 5 is a factor of the x cubed minus, or sorry, x cubed plus 125. So x plus 5 is a factor, goes in and doesn't have a remainder, is a linear factor. All right, now I've got just two examples here at the bottom. There's going to be questions that ask you, to factor completely. And so what do I mean by that? We're going to go ahead and use synthetic division here. So I'm going to change this to a 2, and I have 1, negative 16, 76, negative 96. We don't have any missing powers of x here. 2 times 1 is 2. This will be negative 14. 2 times negative 14 is negative 28. And this is going to give you 48, and this will give you 96. So this is a factor. Okay. Remainder is 0, constant, x squared. Here's what this means. X minus 2 times x squared minus 14x plus 48 is exactly equal to this x cubed minus 16x squared plus 76x minus 96, if I can fit that on there. Okay, now this says completely factor. What they're trying to tell you there is whatever you ended up with as your answer, which we got this x squared minus 14x plus 48, we can factor that further. Okay, now if we haven't done this in a minute, so I'm just looking at this quadratic. I need two numbers that when I multiply them I get 48. Same two numbers, I'm going to add them to get negative 14. So what I'm going to use there is an x minus 6 and an x minus 8. And then this is what we call the completely factored form, because the quadratic that we got here as our answer when we first started can be factored further. So that's what we're doing there. Now I have one more. This is given in a little bit different manner. So we're going to factor a polynomial here, and instead of giving us a linear factor, they're giving us a 0. So you have to think about what would the corresponding factor be. So x minus 5, or x equals negative 5 would correspond to x plus 5 as the linear factor. So if they give you a root or a 0, think about that. Okay, so what we're going to do here, and if they actually give you the 0, that's what you use for the synthetic, but this is going to be the form of the factor here, x plus 5. So I'm going to do negative 5. Write down your coefficients. You're not missing any powers of x here, so 1, 8, 5, and negative 50. Bring down the 1. Negative 5 times 1 is negative 5, and then we're going to add the numbers stacked on top of each other. That's going to give me 3. Negative 5 times 3 is negative 15. 5 plus negative 15, negative 10. Negative 10 times negative 5 is 50. And we should get this as a result. If they give you a 0 or a root, then you should not have a remainder. It means that this is definitely a factor. So there's my remainder, my plain number, my x, and my x squared. So what this means is x plus 5 times x squared plus 3x minus 10 is going to be equal to our x cubed plus 8x squared plus 5x minus 50. We want to completely factor it, so that just means that this can be factored further. So I got to multiply to get negative 10 and add to get 3. So the two numbers that are going to do that, are going to be, let's see, x, like let's use a -2 and a 5. X minus 2, -2 times 5 is -10, -2 plus 5 is 3. Other thing I could do here is, since two of the factors are the same, I could write it like this: x plus 5 squared and x minus 2. And then this would be the completely factored form.